Please pause the video and give students 2 to 3 minutes to answer these two questions. Students, this is the same data and the same scenario that we did a warm-up from last week involving the percent of residents that are age 65 or older in the 50 states. The first question asks about the shape of the distribution. The second asks for the median. Please pause the video now. For the first question, we are looking at the shape of the distribution. And so remember, with a stem plot, you can kind of rotate your head to the right a little bit and it kind of turns into a histogram. And so if I kind of smooth over these curves, I see some skewness. And it's definitely skewed in this direction, which if I have my head turned correctly is to the left. Slightly skewed or strongly skewed, I think that's your call. I would go with D, slightly skewed to the left, but as long as you identify the shape as skewed left, I'm okay with it. They would never ask something this subjective on the AP exam. So as long as you can identify it as being skewed left, I'm okay. The second question asks for the median. Now you could have taken the time to count how many observations there are, but once you do, you see that there are 50, and then you kind of say, duh, because this is data for the 50 states, so I should have 50 observations. If I add 1 and I divide it by 2, I get 25.5. So the median is going to be the average of the 25th and 26th observation, counting from either end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. So it's going to be between these two. So 12.7 and 12.8, which if I average those together, I get 12.75%. The closest answer is A, 12.7%. So last week, we talked about what we meant by summarizing a distribution. Can you guys just shout out for me what 3 things you have to address when you're summarizing a distribution? I'm hoping that at least most of you remembered center, shape, and spread. And hopefully you also remember that those need to be given in context. If this is about bunny rabbits, it needs to be clear to me that the problem is about bunny rabbits. Last week we covered center and we covered shape. And so today I want to talk to you about spread. The first measure of spread that we can give is called the IQR, or the interquartile range. The interquartile range is defined as the difference between Q1 and Q3. So in other words, you're going to take the upper quartile, Q3, and the lower quartile, Q1, and subtract them. While we're on the subject of the IQR, I want to talk now about how to actually mathematically calculate whether or not an observation is an outlier. Generally speaking, we can call an observation an outlier if it falls 1.5 times the IQR above the third quartile or below the first quartile. Now I know that sounds complicated, but it's not too bad. This is called the 1.5 times IQR rule. Statisticians have a tendency to name things exactly as they are. And so let's go ahead and just start with an example using the age data that we kept coming back to last week. So let me bring up that data. Okay, and we showed last week how to calculate the 5-number summary. And so let's remind ourselves that's the min, Q1, the median, Q3, and the maximum. And those were 180, 204, 208, 212, and 217. Okay, so how we're going to do the 1.5 times IQR rule. The first thing we need to do is calculate the IQR. The IQR is Q3 minus Q1. So that's going to be 212 minus 204, which is 8. So we have the spread of this distribution. The spread of this distribution is 8 months. It's an IQR of 8 months. That's one way of measuring spread. We'll talk about others. The next thing, as the rule suggests, we need to take that IQR and multiply it by 1.5. So 8 times 1.5 gives me 12. That is not the IQR. 8 was the IQR, but it is my magic number. Okay, there's not a real word for it, so I call it our magic number. Then what I'm going to do, I'm going to take Q1 minus 12 and Q3 plus 12. Okay, so whatever you get for your magic number, do Q1 minus that and Q3 plus that. So Q1 is 204 minus 12 gives me, is that 192? And then Q3 plus 12, 212 plus 12 gives me 224. Now, why have we done this? What this means is that anything between 192 and 224 is not an outlier. Anything outside of that is an outlier. So really the first place we should look is our min and our max. Our min was 180. That's below 192. So that's an outlier. Let's see if we have any other lower outliers. What's the next highest after 180? I think it's 194. 194 is above 192. It's within this range. So that's not an outlier, which means that the only lower outlier is my minimum, 180. 224, let's look at our maximum. It was 217. 217 is within this range. So 217 is not an outlier. And if the maximum's not an outlier, then I don't have any other upper outliers because 217 is the biggest. So 180 is an outlier, but nothing else. Which makes sense because if you recall the box plot that we made showed 180 as an outlier and everything else as belonging on the box plot, meaning not an outlier. Okay? So 180 is enough below the rest of the data to be considered an outlier. Remember, in this class, we're always going to do that modified box plot. So this last bullet point that says outliers, that says outliers on a box plot, we're going to show outliers on a box plot with an asterisk or a separated box or something like that. So we can do a little asterisk and then the rest of the box plot, which this is exactly how I told you not to draw a box plot. I just wanted to demonstrate the outlier. Before we move into other measures of spread, I want to give a quick debrief of the hair lab that you did on Friday. So my first question for you is, what did each residual string represent? So everybody had a piece of white string, which was your hair length, and everybody had a piece of red string, which represented the mean hair length, and then you line them up together and you cut the residual, you cut the extra. So some of you had a white residual and some of you had a red residual. What did that represent? Well, it represented how different your hair was from the mean. If you had a white residual, then that meant that your hair was that much longer than the mean. And if you had a red residual, that meant that your hair was that much shorter than the mean. So I want to ask you, what would a group's residuals look like if everybody in the group had similar short hair? Okay, well, everybody would have really small, if anything, for their residual, right? Because if everybody's hair is similar and short, everybody's white strings are going to be short, the average is going to be short, and when you line them up, you don't have much to cut. My second question is, what would a group's residuals look like if everybody had similar long hair? Think about that for a second. Well, the answer to that is the same as the previous question, because if everybody has similar long hair, then everybody has a long white piece of string, And the average is going to be long, so everybody's going to have a long red piece of string. And again, when you line them up, there's not going to be much to cut. So these residuals don't tell me anything about an individual's hair, but it tells me about how different each person is from the average of their group. Now, I have a feeling you had a hard time with that last question on the lab, okay, that gave this formula. Let's talk about this formula real quick. Xi represents your hair length, and the mean obviously represents the mean for your group. So this Xi minus the mean represents each person's individual residual. Okay, so each person's distance to the mean. And if I sum all those together, well, what should have happened is that the sum of the whites and the sum of the reds equaled each other, which means the positive and negative residuals balanced each other out, and this would sum to 0. This is very ineffective because most groups probably had some variability, and something that's always going to give 0 is not going to tell me anything about how variable hair length is within your group. So I'm hoping some of you came up with something to fix the equation. Maybe you put absolute value signs around that formula. That would make each person's residual positive, which would mean this would sum to some number that would actually give me meaning. Now, although that's a great suggestion, that's not what we actually do. What we do roughly is we take those differences, those residuals, and we square them. Squaring makes everything positive, or at least non-negative, right? And so we square them, and then we essentially average them together, and we take the square root, okay? Don't copy that equation down. It's not quite complete. This is the actual equation that you want right here. Okay? So this, I'm looking down here at standard deviation, is the square root of the sum of the residuals squared divided by n minus 1. So dividing by n minus 1 essentially averages them together. What I had before I took the square root is something called variance. Variance is the standard deviation squared, okay? This is not a simple concept. If your head is spinning right now, that's okay, all right? What I need you to know right now is that standard deviation is a measure of spread. We abbreviate it with the letter S, a lowercase s. Variance is the standard deviation squared, and so we abbreviate it with an S squared. I need you to know that standard deviation measures the average distance to the mean, the average residual between an individual observation and the mean, okay? If I were in a room with people and everybody was roughly the same height, the standard deviation would be very small. If I were in a room with people with, some people who are really short, some people who are in the middle, some people who are tall, then the standard deviation would be much bigger. So standard deviation is the average distance to the mean. You are probably worrying about this formula right now. The good news is we will not really use this formula much at all, okay? Really not at all. Your calculator can calculate standard deviation beautifully, and you have the calculator for the entire AP exam. So do not let this formula scare you away. Let me show you how to do that right now. So go ahead and get out your graphing calculator. And I'm a little scared, so I'm going to quit. I'm hoping we have the data in our calculator from the ages, but if you don't, please pause the video so that you can enter that data in. So let me clear all this, bring up my calculator, pause the video right now so that you can enter this data again. All right, I do have some good news. You actually already know how to find standard deviation. So I want you to do the same thing you did to find the 5-number summary and the mean, which was go to Stat, and then over to Calc, and one var stats, one variable statistics. Hit enter and then hit enter again. And if you scroll down a little bit, you might not even have to scroll. You're going to see SX. SX right here is standard deviation, okay? So 8.799. is our standard deviation here. Let's remind ourselves what the mean was. I'm going to scroll back up, 206.105. So 206.105 was the mean age. That gives me a measure of center. And 8.799 is the standard deviation of the ages, and that gives me a measure of spread. Okay? Now my next question in terms of the calculator is, what if you have high frequencies? So what I mean is, what if I have a data set that has kind of the same numbers over and over again, not a whole lot of different numbers, but the same numbers happening over and over again. So for example, let's say I'm talking about AP scores. Okay, AP scores can only be 1, 2, 3, 4, 5. But if you look at all of my AP scores from last year, there are lots of numbers, they're just really repetitive, okay? So let's say I'm just making numbers up. Let's say I had 15 students get a 1, 20 students get a 2, 25 students get a 3. I really am making this up. 18 students get a 4, and 10 students get a 5. If I were to list this data set out, it would be 1, 1, 1, 1, 1, 15 times, and then 2, 2, 2, 2, 20 times. I don't really want to put that in my list 1. I don't want to enter 1 15 times and enter 2 20 times, okay? So what I'm going to do, let's go ahead and clear our age data. And what I'm going to do, I only do this when I have a scenario like this. I'm going to put the values of the variables 1, 2, 3, 4, 5 in list 1. And I'm going to put those frequencies in list 2. So I'm essentially constructing a frequency table in my calculator. Okay, so what this tells me, I have 15 ones, 20 twos, 25 threes, 18 fours, and 10 fives. Now, I'm scared, so I quit. When I do stat and then over to calc, and I still select one variable stats because I still have just one variable. The variable is AP score. Frequency is not its own variable. It tells me how often each of those values of that variable occurred, but it's still just one variable. So I'm going to choose one variable stats. Don't hit enter again though, because then it's only going to look at list 1 and it's going to find the average of 1, 2, 3, 4, 5, which is not very interesting. What I need to indicate to my calculator is, hey calculator, my values are in list 1 and my frequencies are in list 2. So the way you do this is by hitting second 1, that's L1, comma. Did you know your calculator had a comma? It's above the 7, next to the parentheses, comma, L2, which is second 2. So I did 1 var stats, L1, comma, L2. And I did L1 by hitting second 1 and L2 by hitting second 2. Now I get a mean of 2.86 and a standard deviation of 1.25. Okay, so the mean, what did I just say? 1.86 and a standard deviation of 1.25. That's how you can handle something like this if you have not much, difference in scores. My only possibilities are 1, 2, 3, 4, 5, but each one occurs many times. To take a second here and pause and make sure you have some conceptual understanding of what standard deviation is. I don't want to reduce it to just here's how you get it in the calculator and not have you worry about what it actually means. Again, it's the average distance to the mean. And I'm going to do this to you with two examples. My first example is the data set 5, 5, 5, 5. It's not very interesting. What is the mean of 5, 5, 5, and 5? Well, I can add them up and divide by 4, and not surprisingly, I see that the mean is 5. Now, how far is this observation from the mean? Well, it is equal to the mean, so it's 0 away. This one is 0 away. This one is 0 away. And this one is 0 away. So each observation is exactly equal to the mean, so the standard deviation, or the average distance to the mean, is going to be 0. So the mean is 5, the standard deviation is 0. Let me give you something similar. 0, 0, 10, 10. What's the mean? Well, I can add these up and divide by 4, and I see, again, not surprisingly, that the mean is 5. Now, how far is this one from the mean? Don't worry about positive or negative. It's 5 away. Yes? This one is 5 away. This one is also 5 away. And this one is also a distance of 5. So they're each 5 units away from the mean, which means the average distance to the mean is 5. So we see these two data sets are very different. 5, 5, 5, 5 and 0, 0, 10, 10, that's pretty different. They have the same mean. So if we only looked at center, they'd be the same. But the spread, in this case the standard deviation, shows me that they are in fact different. Okay, so to summarize, center, shape, and spread. Your shape options are approximately normal, uniform, skewed right, skewed left, and bimodal. My advice to you here is to pick one. Students have a tendency to want to, I don't know, hedge their bet or something like that, and they say something like, well, the shape is approximately normal, but it's a little bit skewed right, and I can also see how it could be uniform, and you know what, there's kind of a second bump there, so it's also bimodal. Okay, you've now told me that it's 4 out of the 5 shapes. Not okay. Pick one. For center, you can either find the mean or the median, whichever is easiest for you to find in that scenario. And for spread, you can give the range, which we've talked about already. That's max minus min. That's probably the easiest one. You can calculate the standard deviation or the variance if you're really feeling like it. Or you could calculate the interquartile range. Okay, you could do any of these for spread. So a statement might say something like the distribution of AP scores was skewed right. I'm just making this up, by the way. With a median of 3.1 and a standard deviation of 1.9. I have not used the words center, shape, or spread, but I've addressed all of them. Skewed right, address the shape. Median, address the center. And standard deviation, address the spread. You could also give these in bullet points. That's just fine, as long as you include the context. Now here's homework number 4. It's a short assignment, but I actually want to take a moment and review a couple things with you because I think we're going to have time. This video isn't too long so far. So let me review with you really quick. First of all, I want you to pause the video and I want you to test this set of data for outliers. Now you can enter the numbers in your calculator if you want to find the 5-number summary, but I don't want you to just make a box plot and look and see if there are outliers. I want you to actually perform the calculation. So please pause the video here to practice testing for outliers, and please help your neighbor if they need it. So as a quick reminder, I entered the data in my calculator. I saw that there were 18 entries, which matched what I saw. I went to Stat, Calc, one variable stats, and I calculated the, I don't know, the mean, the standard deviation, the 5-number summary, some other stuff that we're not sure about yet. I see that the mean is 543.88 and the standard deviation is 143.82. If I scroll down, I see the 5-number summary, which is 250, 480, 510, 610, and 800. I'm going to come back to my problem, and I'm going to remind myself of the 5-number summary, which was 250, 480, 510, 610, 800. If you recall, the first thing I need to do is calculate the IQR, which is Q3 minus Q1, 610 minus 480. That should be 130. Then I need to take that number and multiply it by 1.5. When I do that, I get 195. That, remember, is my magic number. Okay. I'm going to do Q1 minus 195. That's 480 minus 195, which is 285. And then I'm going to do Q3 plus 195, which is 610 plus 195, which is 805. Now, I know that SAT math scores can't go above 800, and I also know that my maximum is 800, so there are no upper outliers. What I need to see is if I have anything below 285. I see that my minimum is 250, so 250 for sure is an outlier because it falls below that lower bound. The next highest that I see is 390, which is within that range, so I only have one lower outlier, and that's at 250. As I mentioned before, you have your first quiz on Wednesday. Tomorrow there won't be a video. You'll just have class time to rewatch videos on your own device, work on homework questions, ask each other questions. I just ask that you're all on topic and working efficiently because we really, really, really need to stay on top of this material. For the quiz on Wednesday, you're responsible for all graphical displays. So those include dot plots, stem plots, histograms, ogives, box plots. I put bar graphs on here, but that's definitely less important. You are responsible for being able to calculate the 5-number summary and then test for outliers. That's the 1.5 IQR rule that I just taught you. And you need to be able to describe a distribution or summarize a distribution. I would say this is the biggest skill. So you need to be able to give center, shape, and spread, even if I don't use those words. If I say describe or summarize this distribution, you need to be able to understand that that's center, shape, and spread, and you need to know how to give each of those in context. So our measures of center, what were those? Those were mean and median. So whichever of those is easier for you to find. Shape, our possibilities were what? Bimodal, uniform, skewed right, skewed left, and approximately normal. And then our measures of spread were range, it's the easiest one, IQR, or interquartile range, standard deviation, and variance, which is just the standard deviation squared. Again, as a reminder, here is your homework number 4. Tomorrow is a review day, and then your quiz on everything we've done so far is on Wednesday.